Mr. Z back with you here, covering 1.5 graphing and sketching polynomials. This is the second part. We're going to be sketching polynomials now. So recap last video, we learned writing polynomial functions given the roots for given a graph. In this video, we'll talk about sketching polynomial functions. So first, we need to identify y-intercept, x-intercepts, their multiplicity, and then identify their end behaviors. So let's go ahead and get started on that. First one here. We're going to be sketching this now. The next slide I actually have where I can sketch it. First, though, let's go ahead and do the first 3 steps. There's 4 steps to this. And I'd probably go ahead and take notes of how those 4 things, like being the real bullet points, what we're doing. We're identifying the y-intercept. Well, identifying the y-intercept, for number 1, to identify the y-intercept, we let x equal 0. So if I let x equal 0, I'm going to get, then y is going to equal -2. So that gives me a point, 0, -2. Next, I want to identify the x-intercepts and their multiplicity. So that gets a little more complicated in this case. In this case, I'm going to go ahead and look at that left side. I'm going to go ahead and factor it. If I have a factored polynomial, it's easy. But in this case, it's not factored. And when I glance at it, I notice it seems as though there may be a common pairing here between these 2 pairs. So I'm going to go ahead and factor out a -x squared. And that's going to give me, if I divide x cubed, -x cubed by -x squared, I get a positive x. If I divide the second one, I get a -2. If I divide it by -x squared. Now, I say this is +1 times x minus 2. And that tells me that I have, and this got messy a little bit. I have -x squared plus 1 times x minus 2. And I'm going to go ahead and take a -1 out of there and get x squared minus 1, x minus 2, with that -1 being outside. So right now I have an x minus 1, x plus 1, x minus 2. Now with all that in mind, that tells me that I definitely have some values here that give me my zeros. My 0 here is 1. My 0 here is -1. My 0 here is 2. Now notice, none of them are squared or raised to the 3rd power or anything like that. So all of them have the same multiplicity. Those are the zeros, and they all have a multiplicity of 1. So I identified the x-intercepts. The x-intercepts are 1, -1, and 2. And their multiplicity is 1. Identify the end behavior. Well, I have a 3rd degree, but remember, if I look at a normal 3rd degree equation, it looks like this. But in this case, I have a negative out there, so it's going to flip it. It gives it the mirror. So I would expect it to go like that, which means my end behaviors, identifying the end behaviors here for my 3rd step, I would say the limit as x approaches -infinity for this function would equal a positive infinity. That's from the left side. And from the right side, the limit as x approaches positive infinity, f of x is going to equal a negative infinity. So that's how my n behaviors. So I have all that information. I have my y-intercept. My y-intercept for 1 is here. My x-intercepts are at 1, -1, and 2. So they go through 1, 0, -1, 0, and 2, 0. And then those n behaviors that we were talking about are right here. So using that information, I should be able to graph. That equation. So let's go ahead and move on. With that information, now we sketch it. I said my 1, 0, -1, 0, and 2, 0. And my y-intercept was 0, -2. I could go ahead and calculate, say plug in -2, I get, let x equal -2. That's going to make that -8, a +8, plus a negative, wait, that's going to be positive, so it's going to be +8, -2, -2. That's 16, -2 is 14, -2 is 12. So that gives me -2, +12 as another point. So that's going to go up to here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's going to be up there. And I would say I could go ahead and graph this as that. It's going to come back up here, go like that, and then go down. And notice, I still do have some real key points that I have graphed on there. And maybe go ahead and put in 1, 2, 3. And you can find out it's probably going to be also going down pretty fast. So I think that's a good enough sketch for that one. The next one, we have one more example here. They wanted us to sketch an inequality. And again, we're going to identify the 0. I'll try to move along a little faster here. We have, if I have x equals 0, wait. I'm graphing this polynomial. I don't have a y. I can't graph it on a two-dimensional space if I don't have a y. So what I like to do is go ahead and move everything over. I have x squared minus 4x minus 12 is less than or equal to y. So in that case, if I want my y-intercept is going to be when x equals 0, I put in 0 for those first two terms, y is being -12. So I'm going to go ahead and say that's my y-intercept. My next step, find my x-intercepts. Well, if I factor this, I have -12, factors of -12 that are going to give me a -4. And I would say that's -6 and +2. So I'm going to go ahead and factor that as x minus 6, x plus 2, less than or equal to y. So my x-intercepts would be -2, 0, and 6, 0. So I have my x-intercepts, my y-intercepts. Notice their multiplicity here again is still 1 for both of them. And then identify the end behavior. Remember, this is a parabola. And the way I've written it, the a is positive, so that it's going to have this sign. So again, limits as x approaches negative infinity for the function will equal positive infinity for both the left limit and positive infinity. The right limit will also be a positive infinity. So I've covered all those three things that I need to do. And when I do that, the only other thing I thought of, this is a regular parabola. You might want to remember the vertex. They didn't ask us to find it, but the vertex is x equals negative b over 2a. Negative b is opposite of negative 4, which is a positive 4. 2a is 2 times 1. So the vertex should lie when x equals 2. And if I plug in 2, I get 2 squared minus 4 times 2 minus 12 is going to be 4 minus 8 minus 12, negative 4, negative 16. So in actuality, my vertex should be at 2, negative 16. So I've gotten one more piece of information. I have my y-intercept, my 2 x-intercepts, and my vertex. And using those things, when we go to what they've given us as far as a graph, I'm going to go ahead and recognize that this only goes down to negative 10. So I'm going to go ahead and write these as 2, 4, 6, 8, 10, negative 10 here. Oops, I should write this a little nicer. 1, 2, 3, 4, 5 is at negative 10. And I'm going to go ahead and do that for all of them. I'm going to go ahead and just double everything. So 2, 4, 6, 8, 10. 2, 4, 6, 8, 10. 2, 4, 6, 8, 10. And that allows me now to use what we just had there as my vertex being at 2, negative 16. That's 2, 10, 12, 14, 16. That's going to be right there. It's going to be my vertex at 2, negative 16. Remember my x, one of my x-intercepts is at 6, 0. That'd be 2, 4, 6 there. And then my other one's going to be at negative 2. It's going to be here. So those are three really important points. I can go ahead and, knowing that this is a parabola, get a pretty good idea that it's going to be something like that. So using that information from the last slide, I have my vertex, my 2 x-intercepts, and my y-intercept. What did I say my y-intercept was going to be? My y-intercept is going to be 0, negative 12. It actually should be right here. So that point. So I have this point, this point, this point, and this point. And if that's the case, then this should also be the case. So I was a little bit off the course. Okay, and that's about it. So, but wait, this is an inequality. Now we do include the lines, but to graph it, now remember, this is 0, 0. If I put in 0, 0, 0 is less than 0 plus 12. 0 is less than or equal to 12. Therefore, it's going to be here is true. That was my test point. So if that's my test point, I'm going to go ahead and shade in. Let me see. Actually, let me put highlighter. And then this is going to be here. And that's going to be the shaded in region, including the line. So That would be my graph or sketch of that inequality. Again, I tested a point, and I realized it was going to be inside. If that would have been negative, I would have been graphing outside. I was shading outside. And that's it. That's how you would graph that inequality. So next steps, complete the delta math. And that delta math has the name 1.5 graphing polynomials on it. And then you also have a mastery check. Thank you very much, and have a great day.